Hi folks, we're going to take a look at the solution to number 2 from the Unit 5 extra review questions. So they're asking us to solve this equation on this interval here. So the first thing I notice is I've got inputs of 3x. Now normally that might worry me, but in this case here, because both trig ratios have the same input, I don't think that's necessarily going to cause a problem. So I'm going to focus on the fact that here I've got a cosine and here I've got a sine. Okay, but we've seen this type of thing before, especially where one of them is squared, because I can use my Pythagorean identity now to change this sine squared into a cos squared. Okay, so let me start by doing that. Okay, so here sine squared of a is equal to 1 minus cos squared of a. So the sine squared here is just equal to 1 minus cos squared of, in this case here, 3x. Okay, now notice here I didn't bother putting brackets because I had an addition, but you might want to do that if you ever forget to do it when there's a subtraction there. Okay, and so now I've got something which looks a lot more familiar. This looks like a quadratic trigonometric equation. Okay, so let's bring everything to one side. Now because my coefficient to my quadratic term is negative, I'm going to bring everything to the right hand side to make that positive. I just prefer working that way. So this just becomes positive cos squared of 3x. Bring that to the other side, so it'll become minus 2 cos of 3x. And here I actually have 1 minus 1 is 0. There you go. They cancel out. So I actually end up with something a little simpler. Okay, so when I've got just these two terms, all I have to do is factor out the common factor of cos 3x. So 0 equals, so factor out cos 3x, and what I'm left with here is well, I have another cos 3x there, and here I'm just left with minus 2. Okay, and I have exactly what I'm looking for, two expressions that multiply to 0. So that means either cos 3x must be equal to 0, or cos 3x minus 2 must be equal to 0. Okay, and I'll deal with this one right away because this is going to end up being the easier one, because this means that cos 3x has to be equal to 2, which of course we know is impossible because cosine can never be larger than 1. So right off the bat I can eliminate any answers that come from that second part. Okay, so now I just have to deal with cos 3x being equal to 0. So I can use my inverse trig function. Unfortunately, that's not going to give me an exact answer, but I know that there's going to be special angles that have a cosine of 0. Okay, in fact, we should know that it's at pi over 2 and 3 pi over 2 that cosine is going to be equal to 0. So whether I use my Cartesian plane or I remember the graph of cosine, which of course is 0 at pi over 2, 3 pi over 2. So those are the two answers that I get. So 3x can be equal to pi over 2, or 3x can be equal to 3 pi over 2. Okay, and so now I can solve for x. So x is either equal to pi over 6, or x is equal to 3 pi over 6, which of course is just equal to pi over 2. Okay. But, of course, there's many more answers because they want all the possible answers between negative 2 pi and pi. Okay, so now I have to use the next part is to use the period of my expression. So in this case here, because I have 3x, my period is equal to 2 pi over 3. Okay, so now let's start adding and subtracting that. Let's start with this left one here. Now, since I've got pi over 6, I'm not going to think of 2 pi over 3. I'm going to think of 4 pi over 6 to do my addition and subtraction. Okay, so let's find the next. Let's add pi over 6 plus 4 pi over 6 is going to be 5 pi over 6. So there's another answer. Let me add another 4 pi over 6. So that's going to be 9 pi over 6, which of course can just be written as 3 pi over 2. Okay. But if I add 9 pi over 6 plus another 4 pi over 6, well, I'm going to end up with 13 pi over 6. That's too big because that's more than 2 pi. Remember, I'm only going up to 2 pi. Okay, so let's find, so here, 1, 2, 3 answers so far. Let's start subtracting. Okay, pi over 6 minus 4 pi over 6, okay, gives me negative 3 pi over 6. which is just equal to negative pi over 2. Okay, negative 3 minus another 4 is going to give me negative 7 pi over 6. That's still good. And if I subtract another 4, that's going to give me negative 11 pi over 6, which is still greater than negative 2 pi. But if I subtract another 4 pi over 6, I'll be outside of my range. So I've got from this first part 1, 2, 3, 4, 5, 6 answers. Okay, so quite a few. Let's now start working with the pi over 2. Okay, so here, again, I'm adding and subtracting 2 pi over 3, so I'll think of this as being 3 pi over 6, okay, plus 4 pi over 6 gives me 7 pi over 6. So there's another answer. Let's add another 4 pi over 6. That's going to give me 11 pi over 6. That's still good. But if I try to add another 4 pi over 6, I'll be above 2 pi. So that's it for my positive answers. Okay, so let's now subtracting. So remember, let's write this as 3 pi over 6 minus 4 pi over 6. Well, that's going to give me negative pi over 6. Okay, let's subtract another 4, so that's going to be minus 5 pi over 6. Let's subtract another 4, that's going to be negative 9 pi over 6, which is just negative 3 pi over 2. But if I try to subtract another 4 pi over 6, it'll be negative 13 pi over 6. That's too small. Okay, so I've got here my 3 negative answers. So in the end, even though we were left with just this, innocuous looking equation, it actually ended up producing 12 solutions between negative 2 pi and 2 pi. Okay, so let's review. Number 1, I had some sort of quadratic trig equation. I used my Pythagorean identity to turn it into one that I could work with. Okay, in this case here, I was able to use factoring to help solve the problem. Okay, and it turns out that only one of my factors help determine a solution. Okay, and as we did before, we start by finding our first 2 answers. Okay, and then from there we can just add the period, which in this case here was 2 pi over 3, over and over again, or subtract the period over and over again until I get all the answers within my range. Okay, that's it for this one.